Hello, hi everyone. Welcome to the Stone the Brand. So this is our Siva sir. Today we are going to discuss about light refraction. So in the previous video, once check my previous video. In the previous video, I explained about light refraction, light reflection. In this video, I am going to explain about light refraction. Okay, so light refraction, I'm going to explain. So let's start. So now this is a rarer medium and denser medium, light refraction. Refraction is nothing but the path of the light changes at the interference of the two media. The light ray is moving from one medium to another medium. At the interference of the two media, the path of the light changes. Okay, the path of the light changes. So that one is known as refraction of light. Refraction of light. So here you can see this is a rarer medium and denser medium. So I am taking this incident ray and this one is a normal line. So we are drawing with the normal line. We are drawing the normal line with the dotted line because so it's not existed for our understanding sake. We are drawing, and here so we can take this refracted, rarer medium, denser medium. So incident ray, incident ray, and this one is the refracted ray. And the angle between incident ray and normal line is called angle of incidence. So angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. So here you need to understand one thing. So angle of incidence is greater than the angle of refraction in case 1. Okay, in case 2, coming to case 2, okay, so here I am taking if the rarer media and denser medium, light ray is moving from denser to rarer, it moves away from the normal line, so here you can observe. Okay, so this is the angle of incidence and angle of refraction. So incident ray, refracted ray, Angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. Now in this case, angle of refraction is greater than the angle of incidence. So why? So here you can observe the path of the light changes when it is moving from rarer to denser. So at the interference of the two media, it changes its path. Okay, so here you can observe this is a rarer medium and denser medium. Light ray is moving from rarer to denser, it bends towards the normal line. Incident ray, refracted ray, angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. Okay, so it bends towards the normal line because here you can observe angle of when it is moving or when it is bending towards the normal line, so refracted angle is less compared to angle of incidence. So angle of incidence is greater than the angle of refraction. Okay, and in this case light ray is moving from denser to rarer, so angle of refraction is greater than the angle of incidence. Angle of refraction is greater than the angle of incidence because when it is moving from denser to rarer, the speed of light is increasing. That's why it is moving away from the normal line. So angle of refraction is greater than the angle of incidence. So this is about refraction of light. Okay, so next one, so we'll discuss about Okay. So here you can observe if the light ray is passing along the surface. So I am taking the glass. Here I am considering like this. This is a glass slab. This is a glass slab. So incident ray. This is incident ray. Incident ray. The light ray which is perpendicular to the plane surface is called normal line. This is a normal line. Okay. And this one is the refracted ray. Refracted ray. And the line which is perpendicular to the plane surface is called normal line again. Okay, so here you can observe this incident ray, refracted ray, and the light ray which is emerging out or moving out or coming out is called emergent ray. So here you can observe this is the emergent ray. Emergent ray. And so you have to extend the initial direction of the incident ray. So this incident ray I am taking. Incident ray and refracted ray and emergent ray. Incident ray. So this is the incident ray. Incident ray. Incident ray, and this one is the refracted ray and this one is the emergent ray. Okay, emergent ray. So the angle between incident ray and normal line is called angle of incidence, and angle between refracted and normal line is called angle of refraction, and the angle between emergent ray and normal line is called angle of emergence. Okay, so if you are extending the incident ray, so the direction of the incident ray like this. Okay, so it will be like this. So the distance between emergent ray and initial direction of the incident ray is called a lateral shift. Lateral shift is called lateral shift. Okay, so incident ray, normal line, refracted ray, normal line, emergent ray, normal line, and the angle between incident ray and normal line is called angle of incidence. Angle between refracted and normal line is called angle of refraction. Angle between emergent ray and normal line is called angle of emergence. And the distance between emergent ray and initial direction of the incident ray is called lateral shift. Lateral shift. So coming to the vertical shift. Vertical shift is nothing but, so here a beaker is here. This is a beaker. Okay, I am taking the beaker. So the person is standing here. The person is standing. Okay, so at position A. So I place the coin in the beaker. So here, this is the coin. So I place the coin at the bottom of the beaker like this. Okay, so this is the beaker at the bottom of the beaker, and so we can't able to see the coin. The person at position A can't able to see the coin placed in the beaker. So after pouring water, so if you pour water, the coin position rises up. Okay, so the coin position rises up. So it will be rise certain distance. So here it will be like this. Okay, so I am taking here. So here I am taking this position of the coin, and actually the position of the coin is there at the bottom of the beaker, this upper end position. So the distance between actual position to upper end position is called a vertical shift. So the distance between actual position to upper end position of the coin is called vertical shift. Okay. So the distance between emergent ray and extended incident ray or initial direction of the incident ray is called lateral shift. Lateral shift. Okay. So that is about vertical shift, and this is about lateral shift. And even if you place the pencil in the beaker, so I am taking here beaker. Okay, so water is placed here. So I'm placing the pencil. So here you can observe, I place the pencil over here. So this is the pencil like this. Okay, so I'm considering like this pencil. So at the interference of the two media, so I'm taking here like this. So at this position, at the interference between water and air, at the interference between water and air, so the pencil appears to be bent. At this position, the pencil appears to be bent. Actual position is little down itself, so it will be little down, so like this. Okay, so it up actually the position of the pencil is here. This actual position of the pencil. So because of refraction of light, the pencil appears to be bent. Okay, at the interference between air and water. So air and water, this is the water. Okay, so at the interference between air and water, the pencil appears to be bent. So due to refraction of light, due to refraction of light. And one more thing, if you are placing the beaker, so inside of the beaker water is there. If you place the lemon, I am placing the lemon. Okay, lemon I am placing. So lemon. So it appears bigger. So due to refraction of light, the lemon placed inside of the beaker, it appears bigger. It appears bigger. Okay. So these are the examples for refraction of light. So once again, observe carefully here. So incident ray, refracted ray, emergent ray. So the angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. Angle between emergent ray and normal line is called angle of emergence. And here you can see the initial direction of the incident ray. Okay, this is the initial direction of the incident ray. The distance between emergent ray and initial direction of the incident ray is called lateral shift. Okay, so this emergent ray. And so beaker I am placing, so beaker is here. So the person is standing over here. Okay, so the initially the coin is placed at the bottom of the beaker. The coin is placed at the bottom of the beaker. Here this is the coin. Okay, after pouring water, so initially the person can't able to see the coin. After pouring water, okay, so the person can able to see the coin position, because so after pouring water, the coin position rises up. So initial position is here. So because of the refraction, the coin position appears here. So the distance between actual position and apparent position is called vertical shift. Okay. And here one more. So if you place the pencil inside of the beaker, so water is there in the beaker. The interference between air and water, at that point, the pencil appears to be bent. And one more point. So if you place the lemon inside of the beaker, okay, it appears bigger. Okay, so it appears bigger because due to refraction of light. So these are the refraction of light examples. So very important. Definitely one question, either three mark question, one question will come on this concept. Either pencil placed in the beaker and a lemon, and glass lab related to glass lab, they will ask about okay, so draw the glass lab and mention the points how the refraction takes place. Okay, how the refraction takes place, so they will ask. And lateral shift, vertical shift, so based on that also they will ask one question. Okay, so that's enough. That is about refraction through glass lab. And now we will discuss about laws of refraction. Laws of refraction. Laws of refraction. Laws of refraction. So now you can observe laws of. So I am taking this rarer medium and denser medium. Light ray is moving from rarer to denser. So this is a normal line, and here I am taking this refracted ray. And the angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. Okay, so this angle is called angle of refraction. So point number 1, incident ray, refracted ray, normal line lies on the same plane. Point number 1, incident ray, laws of refraction, laws of refraction. Okay, so incident ray, refracted ray, normal line lies on the same plane, and the second one is, so the ratio of sine of angle of incident to sine of angle of refraction equal to constant. Ratio of sine of angle of incidence to sine of angle of refraction equal to constant. That is nothing but refractive index. That is nothing but refractive index n. So n is nothing but absolute refractive index. Absolute refractive index can be written n equal to c by v. N equal to c by v. So what is c by v? So speed of light in vacuum by speed of light in medium. That is nothing but absolute refractive index. Sorry, absolute refractive index. Absolute refractive index. Absolute refractive index. Okay. So absolute refractive index is nothing but speed of light in vacuum by speed of light in medium. Speed of light in vacuum by speed of light in medium is called absolute refractive index. Okay. So first medium compulsory you have to take with respect to air or vacuum. Second medium you have to consider with respect to any medium we can take. Okay. First medium compulsory it must be air or vacuum. So n equal to c by v I am taking. N equal to c by v. Compulsory one medium must be vacuum, so in the numerator. Another medium must be any medium. Okay, so either water, glass, like that different mediums we can take. Okay, so refractive index equal to c by v. Coming to relative refractive index. Relative refractive index, if you are taking speed of light in medium 1 by speed of light in medium 2. Speed of light in medium 1 by speed of light in medium 2. Here from this we can conclude that so n is inversely proportional to velocity. N is inversely proportional to velocity. So speed is inversely proportional to velocity. Nothing. Refractive index. Refractive index is inversely proportional to velocity. Okay. Then so that we can take from here n12 equal to n1 by n2, that is nothing but v2 by v1. Okay, so n21, so n2 by n1 equal to v1 by v2. Okay, so here you can observe one thing carefully. Okay, so what exactly? N is inversely proportional to velocity. So n equal to c by v. N is inversely proportional to velocity. So from that we can take, here it's very important. So what are the number comes? Okay, so what are the medium comes first? That you have to write in the numerator. So refractive index of medium 1 with respect to medium 2. Medium 1. Medium 1. So you can check once. So any statement or anything. Medium ones come. So if you are taking air with respect to vacuum, air with respect to water we can take. So vacuum means same only. Air with respect to water, Okay, so if you take here air with respect to water, so which medium is coming first? Air. So that you have to write first. With respect to water, so water is coming next. So water you have to write next. So air with respect to water. So first you have to write air, then you have to write water. So n12, n1 by n2, that is equal to v2 by v1. n1 by n2 equal to v2 by v1. So whatever the number is coming first, that you have to write in the numerator. Next you have to write in the denominator. So next medium. Okay. So first medium is coming n1. So n1 by n2. So whereas here, so sir, you wrote n1 by n2, but here you have written v2 by v1. Why sir? What is the reason? As I mentioned here, as I mentioned earlier, n is inversely proportional to velocity, right? N is inversely proportional to velocity. N is inversely proportional to velocity is nothing but n1 by n2 is equal to v2 by v1, or n2 by n1 equal to v1 by v2. So that is about refractive index. Refractive index. Okay, I hope it is very clear. n12 equal to n1 by n2 equal to v2 by v1, n21 equal to n2 by n1 equal to v1 by v2. Okay, I hope it is very clear. So this is about absolute refractive index and relative refractive index, loss of refraction. So here loss of refraction is also known as Snell's law. Loss of refraction is also known as Snell's law. Snell's law. Okay, that is nothing but incident ray, refracted ray, normal line. Incident ray, refracted ray, normal line lies on the same plane, and the ratio of sine of angle of incident to sine of angle of refraction equal to constant. That is nothing but refractive index. Here refractive index, there are two types of refractive index are there: absolute refractive index and relative refractive index. Absolute refractive index is nothing but speed of light in vacuum by speed of light in medium. Coming to relative refractive index. Relative refractive index means nothing but with respect to two different mediums. Okay, other than vacuum. If vacuum comes, that is absolute refractive index. Okay, so absolute refractive index is nothing but speed of light in vacuum by speed of light in medium. So one medium must be vacuum or air. Another medium we can take different medium other than air or vacuum. If both are same, okay, so two mediums are same, then refractive index is 1. So that's why if refractive index is 1, so the light ray is passing, if the light ray is passing from one to another medium, the light ray does not deviate, because if two refractive indexes are same, light ray does not deviate. Or if the light ray is passing along the normal line, so then also light ray does not deviate. Okay, so in these two cases, the light ray does not deviate from its path. Okay, so one is along the normal line, another one is along the if the two mediums are refractive index are same. Okay, in these two cases. So I hope it is very clear. So this is about refractive index, absolute refractive index, and relative refractive index. Next one, so we'll discuss about okay, so now, so we'll discuss about spherical lenses. Spherical lenses. Spherical lenses. Spherical lenses. Convex lens. Concave lens. Concave lens. Convex lens. Concave lens, convex lens. So optic center F1 to F1, F2 to F2. Okay, so here you can observe, here you have to understand one thing. So convex lens, okay. So convex lens, so optic center F1 to F1, here F2 to F2. So this lens is also known as converging lens. Convex lens is also known as converging lens. Convex lens converging. Convex lens is converging. Convex lens is converging. Convex lens. Convex lens are converging. So converging lens. So why we are calling convex lens is a converging lens and concave lens is a diverging lens? So optic center F1, 2F1, F2, 2F2. Okay, so here, so light rays are coming from infinity. Here you can observe these light rays, what it will do, what lens will do, it diverges the light rays. So convex lens, after converging those light rays will meet at one point. So here if you observe, after refraction, these light rays are moving away from the principal axis. Here if you observe, after refraction, light rays are moving towards the principal axis and meeting at one point. In this case, after refraction, light rays are moving away from the principal axis. These light rays are diverging. Okay, diverging the light rays. If you are extending the reflector light rays, refractor light rays, those refractor light rays are meeting at one point. Extended refracted rays, actual. So that's why here convex lens is also known as converging lens. Concave lens is also known as diverging lens. I hope it is very clear, right? So ray rules of concave lens and convex lens we'll discuss. After that, image formations. Okay, so be ready for it. Optic center F1, 2F1, F2, 2F2. Okay, so ray rules will discuss. Point number 1. So light ray is coming from infinity. After refraction, it passes through focus. Second one, so light ray is coming from infinity. After refraction passes through focus. Light ray is passing through focus. After refraction moves towards infinity. Light ray is passing through optic center. No deviation takes place. So concave lens, 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 optic center F1, 2F1, F2, 2F2. So light ray is coming from infinity. After refraction, light ray is moving away from it. So passing through focus. 1 2 1 2 3 1 2 1 2 3 1 2 1 2 3 1 2 1 2 3 optic center 2f1 f2 2f2 la 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 nani nani Okay, so here you can observe. So convex lens and concave lens. Coming to the convex lens. So light ray is passing through after refraction, it passes through focus. Here light ray is passing through focus after refraction moves towards infinity. Here light ray is passing through optic center, no deviation takes place. And here you can observe light ray is passing after refraction, it diverges the light rays. We are extending those light rays, those are moving. Extended light rays are passing through focus. Here you can observe. So light ray is passing through focus. After refraction become parallel to the principal axis and moves towards infinity, and here light ray is passing through optic center, no deviation takes place. So this is about convex lens and concave lens. Now these are ray rules of concave lens and convex lens. Now we will discuss about image formations. Image formations. Convex, convex, converging, convex, convex, converging, concave lens is diverging. Nani na 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 la 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 optic center f1 2f1 f2 2f2. Object is at infinity. Object is at infinity. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Yes or no? How many light rays? Minimum 2 light rays are required to form the image of the object. Yes. 1 2 3 1 and 2 2 2 2 2 2. Object is in infinity, image is forming at f2. Nature of the image is real and inverted. Size of the image is highly diminished. So point number 1, highly diminished. So what type of image is forming? Real, inverted and highly diminished. Highly diminished. Highly diminished. Diminished. Highly diminished. Diminished. Highly diminished. La 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 Object, where object is placed? Object is placed beyond 2f1. Where image will form between f2 and 2f2. So just take the light ray. Object, one light ray I am taking. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. So I am taking one. It passes through focus. Object is placed beyond 2f1. Object is placed beyond 2f1. 2f1, 2f1. Object is placed at 2f1. 2f1. Object is placed beyond 2f1. Image is formed between f2 and 2f2. f2 and 2f2. Image is formed between f2 and 2f2. What is the nature of the image? Real, real, real. Inverted, real and inverted, real and inverted and diminished, real and inverted and diminished, real and inverted and diminished, 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 real inverted and diminished, 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 diminished. So coming to third one. So be ready for it. Third one. Optic center. F1 to F1, F2 to F2, F1 to F1, F2 to F2. Object is placed at 2F1. Where image is forming? Object is placed. So object is placed at 2F1. Image is formed at 2F2. At F2. Or object is placed at F1. Where image is formed at F2. Object 2F1. Image 2F2. Nature of the image is real and inverted. Real, inverted and same size. So, what is the nature of the image? Real and inverted. What is the size of the image? Same size. Object is placed at F1. Image is forming. Object is placed, oh my god, object is placed between 2F1 and F1. How many light rays are required to form the image of the object? Minimum 2 light rays. Minimum 2 light rays are required to form the image of the object. So now, where object is placed? Where object is placed? Come on. Where is object is placed? Here is the object. Object is placed between 2F1 and F1. Where image is forming beyond F2. What is the nature of the image? Real inverted, real inverted, real inverted, high enlarged. Real inverted, L large. Where the object is placed? Object is placed between 2F1 and F1. Image is formed beyond 2F2, beyond 2F2, beyond. Image is formed beyond 2F2. What is the nature of the image? Nature of the image, nature of the image. Nature of the image, nature of the image, real inverted, nature of the image, nature of the image, nature of the image. Nature of the image is real and inverted, and size of the image is enlarged, enlarged, enlarged. So all of you listen here carefully. It's very important point. Very, very, very serious point. You have to understand one thing. See, you should focus here. You should focus here. You have to focus here. Very, 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 very important. Object is placed between 2F1 and F1. Object is placed between 2F1 and F1. Are you listening? Are you concentrating? Are you focusing? Look at the board. Very serious topic we are discussing. Are you listening? Are you focusing? To you I am saying. To you only I am saying. To you only I am saying. Are you listening or not? Are you? Are you there? Are you there? So instead of scrolling up, just wait here. I am Siva sir, teaching physics class at this time. You have to focus carefully. Focus, 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 focus here. I'm telling. So object is placed between 2F1 and F1. Where is the object is placed? Between 2F1 and F1. Where image is formed? Are you understanding? Our image is formed beyond 2F2. What is the nature of the image? What is the nature of the image? Real, inverted, enlarged. Real, inverted, enlarged. What is that? Real, inverted, enlarged. Where object is placed? Object is placed between 2F1 and F1. Object is placed. Object is placed between 2F1 and F1. Image is formed beyond 2F2. What is the nature of the image? Nature of the image is real, inverted, enlarged. What is that? Real, inverted, enlarged. How it is? Real, inverted, enlarged. Clear? Okay. Object is placed between 2F1 and F1, where image will form beyond 2F2. Nature of the image real inverted, and size of the image is enlarged, 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 real, inverted, real, inverted, real, inverted, real, inverted, real, 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 inverted, real, inverted, enlarged. Okay, so I hope it is very clear. That is about fourth one. Next one, fifth one, fifth one, fifth one, fifth one. So object F1, 2F1, F2, 2F2. Okay, object is placed at F1. Hello, are you there? I'm saying to you only. Are you there? Where object is placed at F1? Are you listening? Where object is placed at F1? Where image is forming? At infinity. Infinity. Object is placed at F1. Image is formed at infinity. Do you know what is the nature of the image? At least do you know what is the nature of the image? What is the nature of the image? Nature of the image is real, inverted, real, inverted, real, inverted, highly enlarged. Okay, na? Once again, object is placed at F1. Object is placed at F1. Where image is formed? At infinity. What is the nature of the image? Real, inverted, real, inverted, real, inverted, real, inverted, highly enlarged. Highly enlarged. Highly enlarged. How it is? Highly enlarged. Remember, highly enlarged. Highly enlarged. Object is placed at F1. Object is placed at F1. Where image is formed at infinity. Object is placed at F1. Image is formed at infinity. Nature of the image is real, inverted, highly enlarged. Highly enlarged. Highly enlarged. Highly enlarged. So come on. So ready. So convex lens. We are discussing about convex lens. Object is placed at infinity. Object is placed at infinity. Are you listening or not? Object is placed at infinity. Image is formed at focus. Nature of the image is real, inverted, highly diminished. Real, inverted and highly diminished. Once again here you can see object is placed at infinity. Image is formed at F2. Nature of the image is real, inverted and highly diminished. Okay, so that is a point number. So image formation. Coming to the image formation 2. Object is placed beyond to F1. Object is placed beyond to F1. Image is formed between F1 to F2. Where image is formed between F1 to F2? What is the nature of the image? Real, inverted, diminished. Real, inverted and diminished. Object is placed beyond to F1. Image is formed between F1 to F2. Nature of the image is real, inverted and diminished. Okay, coming to the next one, third one. Object is placed at 2F1. Image is formed at 2F2. Nature of the image is real, inverted and size of the image is same size. And coming to the fourth one. So which one we are discussing? Fourth one. Which one we are discussing? Fourth one. So object is placed between 2F1 and F1. Object is placed between 2F1 and F1. Where image is formed? Image is formed beyond 2F2. Beyond 2F2. Nature of the image is real, inverted and enlarged. Nature of the image is real, inverted and enlarged. Object is placed between 2F1 and F1. Image is found beyond 2F2. What is the nature of the image? Real, inverted, highly enlarged. Not highly enlarged. So we can't say highly enlarged. You can't say highly enlarged. You can't say highly enlarged because object is placed between 2f1 and f1. How we can say highly enlarged? We can't say highly enlarged. So we can say only enlarged. Are you understanding or not? Are you understanding? Only enlarged we can say. Now I will tell one thing. Object is placed at focus. This time I'm saying to you, this time only I'm saying to object is placed. Where object is placed? At f1. Where image is formed? At infinity. At infinity, what is the nature of the image? Real, inverted, and highly enlarged. Highly enlarged. Highly enlarged. Highly enlarged. Highly enlarged. Yes or no? Now, object is placed at f1, image is formed at infinity. Nature of the image is real inverted and size of the image is highly enlarged. So, this is about convex lens. So, one more image formation is there that we will discuss. So, are you listening or not? Okay. So, if you are there, click on like button. Okay. Just click on like button. So, it will reach to the remaining. So, share to our friends. Are you understanding? Share to our friends. Ask your friends to join to the class. Share as much as possible. So, as soon as possible, as much as possible. Because live class is going on now, right? Live class is going on. Everyone are listening the class. Just you can click on like button. Just tap on like button, just like attendance. Everyone, you are in the class, just if your presence is very important to me, so that's why, so your presence, just click on like button, just click, just smash it, just smash it. Okay, so now we are discussing convex lens. So very important, I am saying very important image formation. Convex lens. Here you can see. So this is a convex lens. Hey, convex lens. Hey, convex lens. Object f1 to f1. F2 to F2, F1 to F1, F2 to F2. Object is placed between F1 and O. Object is placed between F1 and O. How many light rays are required to form the image of the object? Minimum. How many light rays are required to form the image of the object? How many? Can you say me how many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Minimum 2 light rays are required to form the image of the object. Yes or no? Yes or no? Say yes or no. Yes means click on like button. That's enough. Okay, so 2 only. So how many light rays? 2 light rays. So 1 light ray I am taking like this. It passes through focus. And another light ray is passing through optic center. Do you know? Another light ray is passing through optic center. So if you are extending, after extending, after extending, at a certain point, these light rays are meeting at one point. There. See, here. You see, here. Here. So object is placed between F1 and O. F1 and O, image is formed same side of the object. Object is placed between F1 and O. Image is formed behind or same side of the object. Same side of the object. Yes or no? Same side of the object. What is the nature of the image? Virtual, erect, virtual, erect, virtual, erect. So real inverted. So real inverted. So real inverted, real inverted, real inverted, right? Virtual erect, virtual erect, virtual erect, virtual erect. Why virtual erect? Because so image is forming, right? Virtual erect. So real inverted and enlarged is different, but real inverted, real inverted, real inverted. Virtual erect, virtual erect, virtual erect, virtual erect, virtual erect. Okay, so so object is placed between F1 and O. Image is formed between so same side of the object. What is the nature of the image? Virtual erect. Enlarged. What type of image is formed? Enlarged. Compared to the object, image size is increased. This is very important. This one is very important. Compulsory question. 3 marks question. Compulsory question. Okay, so very important. Keep in mind, right? Yes. So I hope it is very clear. So that's enough. This is about image formation by convex lens. Image formation by convex lens. Now we will discuss about image formation by concave lens. Concave lens. Are you listening or not? Concave lens. Click on like button, share to your friends, share as much as possible to everyone. Okay. So this is our Siva sir from Student Brand. So F1 to F1, F2 to F2, F2 to F2. Object is placed at infinity. Object is placed at infinity. Where image is forming at? Where image is forming? Object is placed at infinity. Where is object is placed at infinity? Where image is forming at focus? At focus. Object is placed at infinity. Image is forming at F1. Image is forming at F1. What is the nature of the image? Virtual, erect, 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 and diminished. Diminished. Virtual, erect, and diminished. Virtual, erect, and diminished. So object is placed at infinity, image is formed at F1. Nature of the image is virtual, erect, and diminished. Coming to the next one. Object is placed at infinity, image is formed at F1, nature of the image is virtual, erect and diminished. Now object is placed beyond 2F1, beyond 2F1. Our object is placed between infinity and optic center. Optic center and infinity, how many light rays are required to form the image of the object? Minimum 2 light rays. How many light rays? Minimum 2 light rays are required to form the image of the object. Ten, 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 ten. Ton, 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 ton. Ten, 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 ten. Ten, 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 ten. Wow! Object is placed between infinity and optic center. Image is formed between F1 and O. Nature of the image is virtual, erect. Virtual, erect and diminished. Diminished. Object is placed between here object is placed at infinity, image is formed at F1, nature of the image is virtual, erect and highly diminished. Because image is point size, that's why it is called highly diminished. Because object is formed at a focus, it is highly diminished. Point sized image. Point size image is forming at focus. That's why it is called highly diminished. Next one. Object is placed between infinity and optic center. Object is placed between infinity and optic center. Image will form. Where image will form? Between F1 and O. What is the nature of the image? Virtual, erect and diminished. Virtual, erect and diminished. I hope it is very clear. So this is about, okay. So this is about concave lens image formations. Lali, lali, la 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 la. La 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 So power of lens, reciprocal of focal length is called power of lens. Reciprocal of power of lens. Reciprocal of focal length is called power of lens, or the ability of the eye lens to adjust its power of lens. Power of lens. The degree of converging of lens achieved. The degree of converging of lens achieved. The degree of converging or diverging of lens achieved. The degree of converging or diverging of lens achieved is known as Power of lens, power of lens, power of lens, power lens, power of 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 lens. The degree of converging or diverging of lens achieved is known as power of lens. Power of lens. Power of lens. SI unit of power of lens is diopter. P equal to 1 by F. Simply we can say, the reciprocal of focal length. The reciprocal of focal length is called power of lens. Reciprocal of focal length is called power of lens. P equal to 1 by F. P equal to 1 by F. Power of lens. P equal to 1 by F. And the reciprocal of focal length is called power of lens. Do you know what is SI unit of power of lens? Do you know what is SI unit of power of lens? I know. SI unit of power of lens is diopter. SI unit of power of lens is diopter. Yes, SI unit of power of lens. I know that power of lens is diopter. What is SI unit of focal length? Meter. SI unit of focal length is meter. SI unit of focal length is meter. 1 by F is nothing but diopter. Power of lens is positive for convex lens. Power of lens is negative for concave lens. Power of lens is positive for convex lens. Power of lens is negative for concave lens. Yes. 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 Correct. Okay. So, so yes, sometimes it's required because so continuously teaching, no? So over really 3-4 hours, nearly 3-4 hours onwards I'm continuously teaching. So it happens, but still I'm enjoying my teaching. So I'm happy for it. So if you like the content, if you like the channel, if you like my explanation, please do like, share and subscribe to Student in the Brand. So share to as much as possible. So click on like button. That is only I want from you all. Just click on like button. Share to all your friends. Share to all your friends. Okay. So anyway, we are continuously teaching CBSE Grade 10 Physics. Okay. Notes is available. And sorry. Notes is available and topics are going on. So topics are going on. So continuously we are working on it. Okay. So just from you I need your support, because without your support I can't able to stand here and to do enjoy my teaching point, so teaching path. So without you I can't able to stand here. As I said, I can't stand in front of you itself. So because of you only I'm standing. So please support my channel, support me. So there are many videos are there related to physics. So there are many good content, valuable content, solid content, volume content. Okay, so all physics topics are available. Just to go and check. So go and check and check the videos. If you like the channel, please refer to your friends as much as possible. Share in our groups. So live classes will continue. Okay, so it continues. Live classes, it continues. So without your support I can't stand. So once again, thank you so much for joining and attending and supporting me. So I'm very happy for you all. So because of your support, thank you so much. Okay, so please support my channel. That's enough. That is what I want from you all. Okay. Yes. So now power of lens, the reciprocal of focal length is called power of lens. P equal to 1 by F. SI unit of power of lens is meter. SI unit of Okay, so SI unit of power of lens is diopter. Sorry, SI unit of focal length is meter. SI unit of power of lens is diopter. Okay, so power of lens is positive for convex lens. Power of lens is negative for concave lens. Power of lens is positive for convex lens, and power of lens is negative for concave lens. And here one more point, actually sign conventions will follow the same as it is which we are following for mirrors. Same, those sign conventions only will follow, but here with, so according to the object and image positions it will change. According to the object and image positions it will change. Okay, so I hope it is very clear. So thank you so much for joining. And so this is about light reflection diffraction chapter. Next we will discuss about electric current. Electric current topic also there. Electric current and human in color fluid, magnetic effects of electric current. So electric topics also I'll start. So tomorrow. So do like, share and subscribe to Student in the Brand. Thank you so much. This is what sir. Classes will continue. So this time, so regularly 10 a.m. and 3 p.m. and 6 p.m. and 10 p.m. like that continuous classes are there. So and we will do the numericals also. Numericals also will do it, and concept explanation. And still, if you want anyone want notes, so you can contact to this number. So regarding the notes, class notes, so it's very less cost. So actually, given free, but this time so somewhat valuability is required for actually, because with so much hard work I have written, so my handwritten notes itself, so I only written that notes. So if you want, you can just contact to this number for notes. I'll share the PDF I will share. Okay, so thank you so much for joining and attending. So still I can say thank. So please support. So I need your support. Please share to your friends. Ask your friends to join to the class. Okay, join to the class. Just to go and check my videos. There are many videos are there. Number of videos are there. Okay, so physics content topics are there. Definitions are there. Physics definitions are there. Okay, and light reflection, diffraction, human and color fluid, magnetic effects, electric current, and electricity related to that one, and electricity problems are there, and 100 definitions. There are many definitions. So many definitions are there, many definitions. You can see nearly 5.5k videos are there. Okay, so nearly 5,000 plus videos are there related to physics. Okay, so all are related to physics content only. So just to go and check once, so check the videos, all definitions. So maximum with my soul and heart, so I kept and did those physics videos. Okay na? So try to encourage me, try to support me. Please subscribe my channel. So subscribe my channel, like my channel, and share to your friends. That is what I want. Okay, share as much as possible. Ask your friends to join to the class and learn the concept. Okay, so I am helping you. So at least from your end, so it do help to me. So share to your friends. You are in the name of helping me, you are helping your friends also. Okay, so share your friends, ask them to join to the class. Okay, so classes will be going on regularly, so continuously it goes on. So do support, join to the class, learn the concepts, ask the doubts. So I am always there to you to help. So thank you so much. Signing off. This is your sir from Student in the Brand. Thank you.